Hey guys, Mr. Middleton here. Today we're going to talk about area and volume ratios. At the end of this video, you should be able to use the area and volume ratios of similar solids to find missing areas and volumes. Okay, similar solids have the same shape and all the sides are proportional. Okay, that means that they have the same factor. So if we can say a side is if the height of one prism is 2 times the height of another, then all the corresponding sides will have that same ratio. All the sides will be 2 times the length of its corresponding side of its similar figure. Okay, the ratio of corresponding linear dimensions is called the similarity ratio. Okay, and we did this when we were talking about similar triangles first semester. The ratio of the squared dimensions is called the area ratio, and the ratio of the cube dimensions is called the volume ratio. Alright, if the similarity ratio is A over B, then the area ratio is A squared over B squared. And the volume ratio is A cubed over B cubed. Okay, so that's a relationship that we'll be able to use with similar figures. So here's some examples. 2 similar prisms have a similarity ratio of 3 to 5. What is the ratio of their areas? Okay, the areas, that's the squared units. So we can say, okay, well, their area ratio should be 3 squared over 5 squared, or 9 over 25. What is the ratio of their volumes? Well, volume ratio is cubed, so 3 cubed over 5 cubed, which is 27 over 125. Okay. Given that 2 cones are similar, what is the volume of the smaller cone? Now let's look at what information we're given here. So they gave us that the radius of the smaller cone is 2 meters and the radius of the larger cone is 5 meters. And so from that we can see, since they told us that these are similar, that we have a similarity ratio of 2 to 5. They're now asking us for the volume of the smaller cone. Well, remember that our volume ratio, we can find that by saying, okay, well, if our similarity ratio is 2 to 5, I'll just call this SR, well, then our volume ratio, VR, will be 2 cubed over 5 cubed. We're going to use this. 2 cubed is 8, 5 cubed is 125. We're going to use this to set up a proportion so we can solve for our unknown volume. Okay, the volume of the larger figure is 8,000, and we don't know the volume of the smaller figure. Okay, the smaller number goes on top. So now we have this proportion that we can solve. So we have 8 times 8,000, which is 64,000. 64,000 equals 125x. Okay, so on the screen. Okay, so I'll divide this by 125, and I find that x is 512. Okay, so the volume of the smaller figure is 512 meters cubed. Okay, again, we went from the similarity ratio given the 2 corresponding measurements. Okay, change that to the volume ratio, because the volume ratio is 2 cubed over 5 cubed. Use the proportion and solve the proportion. Alright. Another example, the volumes of 2 similar pyramids are 729 centimeters cubed and 1,331 centimeters cubed. If the lateral area of the smaller pyramid is 60 centimeters squared, find the lateral area of the larger pyramid. If necessary, give your answer to the nearest tenth. Okay, so for a problem like this, notice first that they gave us volumes. They told us these are similar polygons, so our pyramids. So they told us that they're similar, so we know that there's a ratio here. So 729 over 1,331. Alright, so what we're going to do, since this is our volume, say volume ratio. Okay, actually we're volume right now. Since this is our volume, what we're going to do is we're going to see what's the ratio. We can find that ratio just by simplifying this fraction. So in my calculator, I got 729 over 1331. I can just press enter, and then from there I can go press that fraction to decimal, decimal to fraction button. Ooh. Okay, they don't like that anymore. So this is the fraction that we have. Okay, so this is our volume ratio. So now what we need to realize is that this is a cubed over b cubed. Okay, we want to find what a and b are. So in order to find a, I can take the cubed root of 729. Okay, because I want to take the cubed root of 729 so I can find out what a is. When I do that, I get 9. I want to take the cubed root of 1,331. When I do that, I get 11. Okay, so what I found here is a to b. This is my a, this is my b. Okay, now notice that what we're trying to find is a lateral area. Okay, keyword here, area. We don't need to use a to b. We need to use the area ratio, which is a squared to b squared. So when we're going to set up our proportion, I need to have a squared, which is 81, 9 times 9, and b squared, which is 121, 11 times 11, and set that up in our ratio. So they told us that the lateral area of the smaller pyramid was 60 meters squared, so I know 60 goes on top here, x. Okay, and so now I have a proportion that I can solve. 60 times 121, cross multiplying, gives me 7,260 equals 81x. To find x, I divide by 81, and that gives me 89.62. And it says to the nearest 10, so I'll just say 89.6. So x equals 89.6 centimeters squared. And that is the lateral area of the larger pyramid. Okay, so using that ratio to set up a proportion and solving for the unknown measurement. Okay, one last example here on the back. A box of detergent shaped like a rectangular prism holds 3.25 pounds of detergent. How much detergent would a similar box with dimensions 3 times larger than the original box? Okay, so what we're looking at is this pounds is actually a volume measurement. Okay, this is actually a volume measurement. And what they're asking us is, hey, let's change a linear dimension. Okay, if it's 3 times larger, what we're changing is a similarity ratio. What they gave us is a similarity ratio. So really we're at a over b. Say the original one was 1. They didn't really tell us what the length is, but it's the comparison is the important part that doesn't change our ratio. Okay, say 1 to 3. Okay, because the second one would be 3 times larger, right? Well, since they're asking us for volume, then what we're going to do is instead of using a to b, we want to know what's a cubed, what's b cubed. Okay, a cubed will still be 1, b cubed will be 27. So this is the ratio that we'll use in our proportion. We have 1 over 27 equals, the smaller box will hold a 3.25 pounds of detergent, where we don't know how much the larger box will hold. Okay, so cross multiply 27 times 3.25 times 3.25, and that gives us 87.75. Okay, equals 1x. So done. Okay, so if the dimensions were 3 times larger than the original box, then the new box with the larger dimensions would hold 87 and 3/4 pounds of detergent. Okay. All right. So similar to the proportions from last semester, and using volume in there instead of just area and linear dimensions. Okay. All right. See ya.